Hello, everybody. In this lecture, I will be covering chapter 6 and 7, which are model assessment and model implementation. So, let's start first with model assessment. So, what is model assessment? And I have covered this a little bit before too, but I wanted to go a little bit more in detail into this. So we uh, this is our example, the class example which we have been doing, PVA 97 NK. Whether somebody will give us charity or not, target 10, and we have done all this step. We have done decision trees, which can be applied right after data partition. Then for neural network regression, you need to impute data because they are much more sensitive to missing values. Well, they're not sensitive with missing values. They will simply ignore those rows of data, but they're very sensitive to outliers. So we do transform variables and impute to take care of those two steps. And then we put neural network regression. So that's a sort of the class example I did. In your work, there are, you might have done the maximum tree, the decision tree, or polynomial decision tree, and and some other models if you wanna try from here. So what I'm trying to say is that you, for the same data set, to make the same prediction, you might have decision tree, you might have regression, neural network, and multiple kind of decision trees. So once you're done with that, you can go and then look at the results and start comparing them manually, or we have a better way to see which of these, in this case 3 models, are better predictor of our dependent variable or our target variable, which is 1 or 0. So what do? I'm going to go to this top assess, and model comparison, and then you simply connect all these 3 things here, and then you run the model comparison. Okay, so I pause the window a little bit so the result comes up, and they are here now. Let's see the result. And so those are our results which show up. And looking here, it looks a little complicated, but I'm gonna go over a few of the things, and then it will be easy to understand the result. The first thing, let me open, is the fit statistic. First of all, if you remember, we have a validation, a training data set, and a validation data set. So all the results on the various kind of fit statistics are basically representation of how well that model fits with the data and how robust are your result. So those fit statistics you will get for both training and validation data set, but our main concern is the validation data set, because training is, if you remember, we are just training the data set but the validation is where we really test it to see how good its accuracy is. So you will see here the results for both of them. So for example, this is sum of square error for training, and right here is for valid data set. Okay. So all these going on. So there are various kinds of fit statistics available: average square error, ROC index, average error function, gain, Gini coefficient, lift, maximum absolute error, misclassification rate, mean square error, root mean square error, RMSE, which generally we use in statistics, or misclassification rate. So there are a lot of fit statistics available. Generally the one which is considered pretty good, you can go, for example, let me find that ROC index for my validation. There are too many of them. I just saw it. So ROC validation, generally you should expect that this should be above 0.7. Maybe I didn't do all the options for my decision tree here. Maybe I should have done something more better way to do it. I just did it in a hurry. So it should be more than 0.7. If that shows it's a good model. So right now looks like the first one, which is a neural network, is the closest to 0.7. Then you can look at your misclassification rate. That's for the training. Let's find for the validation misclassification. Number of wrong classification, this much. Let me see, square errors. I don't know, I cannot find them. So the misclassification rate for the training is right there, but where is the value? Oh, right here. So as you can see, the misclassification rate is lowest for, again, neural networks. Okay. The other thing you can see, sort of a easiest way to see this Y. So this Y is put to the model selected. So based on the comparison, enterprise minor, based on that comparison node, right here, this node, model comparison is telling us that according to that node, according to the comparison, neural network is sort of the best model. Okay, then you can go into the output variable. You know what, I'm going to come back to that in the last. Then you can, just like your other decision trees you have done, you can make assessments, you can make some charts here and see the results from there as well. Again, target, for validate, for them. ROC chart, actually ROC chart is right there. So that's your ROC chart for decision tree, regression, neural network, and that's your baseline model. So again, I think the neural network is the best, looks like here. And why am I saying that is the best? Let me show you a couple of pictures of what a nice ROC chart looks like. Okay, so that's the okay. So that's your baseline. Gray is the baseline, and that you can see that kind of shape. Less variable to capture is your weak model. This is your strong model, and then weak model is less than 0.06, and that value should be greater than 0.7. Okay. Okay, so now, and then there are some of the other variables you can see. uh, you can see how those three models are doing. But this is the main one where I spend, or I go and look at the data and I try to play around with it. Okay, so again, as you can see, Y means that's the best model. And here is your neural network regression decision tree. And it's showing your, we want the valid one, misclassification rate, and average square rate. So that's one. And then these are your fit statistics. Depend on what kind of research project you are doing. You have to report 3 to 5 fit statistics. I will report this one. Square errors, misclassification rate, some of ROC index is a pretty good one to report. Okay, but let me go all the way. Where are my results, which I was... Okay, oh, right here. So I'm gonna, these are my results for the models, and train, validate, and false positive and negative. I don't know why are there not results for regression. Why are they not reported? It's only decision trees. Let me see what's happening. Let me run it again. Close this. Okay, that's fine. Let me just copy what I have. So these are my results from decision trees and neural network. Let me copy them, and this is what I'm gonna do. I already have an Excel file open, so I'm gonna put those results there, and I'm just doing some... Okay, then I don't need results for training. I am only interested into validation. So I'm just going to remove those. Oops, let me first bring them all in the same column. Looks like this needs to be broken again. Okay, doing something. My... Okay. It's false negative, true negative, and that would be, oops, that would be false positive. Okay, so those are my results. I don't really need training. I'm gonna delete those. Oh, okay. Training goes away. Bye bye. Okay, so now these are my results: false positive, true negative, false positive, true negative. And let me open the slide to remind you what I'm doing. Let me go here. Okay, these are my, which we did in week 1. Okay, so I'm trying to create this. our confusion matrix. If you remember, true positive, something is positive, and we also predicted it as positive. So that is what I'm trying to create here. So first let's do accuracy, or let's do accuracy of each model. So I'm gonna do that formula for each one of them. Okay guys, so I got all these things here, and what I'm gonna do is I got these results, so I'm gonna use this results from the earlier model, because here I have multiple decision trees and regression, probability, everything. So I already ran this. I've paused this video and let me see if the results are in. Okay, so here you can see I got regression and everything here, and it's a little bit more, it will be more fun to look at all those compare all those models rather than just a couple of them. So putting data here, and okay, let me put this here. You know what, I'm gonna pause this video, get this thing ready, and I'll let it run. You can just forward it a little bit if you are watching it. Okay, so that part is done. Okay, so we got those ready. So what's the model? We want that one. Our target is B. I'm going to remove some of these additional which we do not need. Okay, and this is what I am really after. Maybe a lighter color. Okay, so first let's let's just delete all of them. Why to keep the ones which we do not need, training ones. So let's calculate accuracy of our model. So let's start with this, which is true positive plus true negative divided by this plus this plus this plus this. Okay, so that's my accuracy. Okay, and then if you wanna know your true positive rate and true negative rate, that's your true negative rate. So what is your true positive rate? That will be like how many of all the ones which was supposed to be 1 and how many of them we were able to predict. So if something was 1, what percentage of that 1 we could have predicted. Or true negative rate would be if something was 0 out of, let's say, out of the 100, 70 was 0. How many of those 70 even we could predict? So true positive rate, let's calculate that. True positive, this one, divided by true positive plus false negative. Okay, let's do that. And then true negative rate, okay, which would be true negative divided by true plus false positive. Okay, so now you can see overall, if I start with overall accuracy, right? Uh, if I start with overall accuracy, I would say neural network is pretty good. Neural network is pretty good for the overall accuracy. So the overall accuracy of my model is best for neural network, and followed by, I think all of them are pretty close unless I increase the number of, so followed by, you would say, decision tree. So those two are number one. Okay, but then if let's say true positive rate, or this part was very important for you, you are really after this thing, something was positive, and you also want to see that we also predicted as positive. If in your business domain this metric was what you were really after, in that case neural network doesn't do that well. There, look, regression is so much better, because we are now after true positive count. We want to see how many which were ones, we were also able to predict one, followed by maximum tree. On the other hand, if you're after this, something was negative and we also want to have it negative. Again, if that's what your business domain is, that's what is important for your business domain, if that's what you are after, then probability tree followed by neural network is important for you. So as you can see, for each scenario, the results, or based on what we are after, which model is better, changes. So going back to our slides, I wanted to tie this up with something I've talked before. Okay, so that was our accuracy of classification model, true negative accuracy. So again, if you are in spam filtering, medical diagnosis, in that case, false negative, or is much more important. Of course, we didn't calculate false negative. You can calculate false negative as well. But again, if you look, for each domain, different metrics is more important depending on which domain I am in. And so if I just go with the overall accuracy of my model, which is this, I would have gone with neural network. But if I was really after, if my business domain or my business quotient really says that for me the true negative count is the most important, then neural network, probability tree is better than neural network. Same way, if true positive count is the most important for me, then I should go with regression. So what you should take from this, what I want to really emphasize on this, is that SAS help us to run this model, give us all this data, but these results cannot on its own tell us which model to use to make our prediction. We have to connect our business domain and what metric we are really after to the results, and then try to pick up a model. Or you might end up picking a different model for true positive count prediction and different for true negative rate. So you might be using a different model. You might be inclined from that. So what you should take from that, which I've also said before, is that SAS or R or Tableaus, those are all tools. How we use them, and then our business knowledge and business domain matters in us using the information, the results which we get. None of these tools will tell you, okay, use this tree or this model, and that's because that has the best accuracy. This will be perfect for you. No, none of these tools tells you that. You have to, once you get the result, you connect or you add those results with your business domain knowledge, or what exactly is the question you're trying to answer, and then and that sort of produces the best decision support system or decision that enables the best kind of decision making. And so this is you creating this confusion matrix, or at least getting the accuracy and true positive rate and true negative rate from it. Okay. So let me go back here. I think those are all the things I wanted to touch in here. And some of the other things which you can do is once you create this matrix with your result, so you can even associate cost with it. So for example, in our example, PVA 97NK, the one which we are doing, right, this one, we are trying to see if whether we should approach these people to get money from them or not. And as the question said initially, is that when we approach them, we send them an envelope, a small gift, asking them to send money to us, which has a cost associated to it. So if our prediction was that this certain person will give us money, and we send them a small gift and a sort of a letter to give us money, but they did not report it to us, so that would be, we predicted something as positive, but it was negative. So false, it would be a false positive. Something which was negative, we said it's positive. So now you start putting a cost to it. That cost to send that invitation and small gift was $1. Okay. So if we are 40% of the time, let's say this is, I don't want to say 40%, if let's say this is 20%. So 20% of the time we are wrong. So that means out of 100 invitations which we send, and because our system will say that these people will give us money, because 20% time we are saying predicting false positive, that means 20% of the time we said this person will give us money, but 20% of the time that prediction is wrong. They do not. So 20 cases don't give us money, 20% multiplied by how much it cost us to do that action. So $1 envelope gift, $20 loss. On the other hand, you then look at the true positive profit. So if we do send them that $1 gift, and $1 gift, and they give us back on average, let's say $100, $50. So on a $1 investment, we are getting back $50 as charity. In that case, if something like that happens, that we are sending somebody $1 envelope and a gift, and if they do end up giving us money back, we will get $50 back per person. So in that case, the sending out those cards makes so much sense that you can simply ignore everything else, because the returns are so high. And that's the reason you get so many spam mails in your traditional mailbox, because there the true positive, the return is so high that they said that even if we end up saving money, even if you save some money by having a good prediction of other three, it does not really matter. Why? Because the return is so good that even on a $1 return, if somebody's taking that account or becoming a subscriber, the return is so high you can ignore all the three other matrices. So that's why they don't, somebody like spam emails or spam uh, advertisement which you get in your mailbox, they really don't care about any of this decision trees or I mean data mining, because the return is so high with a minimal investment. But when you are talking about credit card transactions, bank loans, medical diagnosis, there it starts mattering, because the other three matrices also has a cost associated with it. Okay. So again, different domain knowledge or different domain, different use of classification models. Okay. So that was chapter number 6. Now moving to chapter number 7, which is what chapter number 7 is model implementation. So what is a model implementation? Once you have this model comparison done, now you want to use a real world data set and try to see how now your model does in a real world data set. So something like what we already did with our validation. Now you are sort of repeating that by getting an external data set and applying your results to that. So in our example, I have already there is a data set called, and this data set is also available to you under your data folder. So it's the one which I'm using is score PVR97NK. Let me do it again. So I'm going to go to my library, selected that. Okay. Next, you will keep on going. Oh, runtime error. What did I do wrong? No. Okay. So you will keep on going up to step number 7. The only thing here is, if you remember, the other data set which we are using, the main PVNK, its role was it was a raw data set. Then we further divided it into partition. We partition it and use half for training, half for validation. Now this data set, I want to use it for score to see how well my new model scores or how well it does. So I'm going to say score. That's the only thing you do. Finish. You drag it down, and then you again go back to your assess and you find score and you connect those to this. So what this will do is, with the model comparison, only the best model out of these three would be used for scoring. So now I'm going to run it. Oh, it's taking quite some time. Okay, so we got the results. Let's go and see the results. These are some of the results. But what I am really after is, I'm going to go to score, exported data. Okay, sorry for the interruption. I had a phone call. So score, then exported data ellipsis. Generally exported data is whatever the result that's get further exported in a file, which you can also take out. Right here is the score, explore, okay. So this is the last one. I'm gonna open it, or before I open it, I'm gonna get all the maximum. Okay, so 20,000. So I had 20,000 rows of data in this new data set, which I'm using to score my algorithm. Okay, so oops. Okay, so if you remember, our target gift flag was either 1 or 0. So let's see how well our best algorithm has done. Okay. Oh, where is it? Okay, right there. So that is your results. And again, your algorithm or your model does not have an exact answer. If something was 1, your model will not predict it as 1 or 0. It will give you a sort of a percentage. So it's saying that it's a chance that 55% chance it would be 1 and 44% chance it will be 0. You can sort it. So I'm sorting it for different cases. So in this case, 70% chance, most of them are 70% chance it's 1. Let's say, is it true? Oh no, it's pretty bad. Yeah. And let's see, 70% chance and above, it's 0. Yep, so those are doing good. So again, so it gives you a percentage. A higher percentage on one side means that there's a highly likelihood that 70% likelihood that it's 0, 30% likelihood it's 1. So that's how it score it's scoring on a real life data set. And our results are not that good, let me tell you that. Okay, so that part was called scoring. So that's all I wanted to cover in this lecture: model comparison and scoring. Remember, to do the score, this file is already under the data folder. So what I did was I went to my data folder, and then I put that file right here. This is my data library, so I put it there. So once it's there, then I can access it from Enterprise Miner. So remember to download that file before you can use it.